Hello everyone, welcome to new class. Today's class is about the problems on mechanical translational systems. So let us go through the problems. Determine the transfer function y2 of s divided by f of s of the system shown in the figure. So this is the figure given. M1, M2 are the two masses given. K1 and K2 are the stiffness of spring. Then B is the viscous friction coefficient. Y1 and Y2 are the two displacements. And F of t is the applied force. So here there are two nodes M1 and M2. So we have to draw the free body diagram first. So there are two masses. So there will be two free body diagrams. One is for M1 and for this M1 and also M2. Next is for M2. So we have to draw two free body diagrams, and here for M1 there is applied force F of t. Then the opposing forces are offered by this M1, K1 and B, and that is marked as FM1 then FB, which are opposite to the applied force, then FK1, and also this K2 is in contact with this M1, so we have to consider that FK2 also, and here the displacement is y1. And for this M2, the displacement is y2. Then two opposing forces are there. One is Fm2, another is Fk2. Now we have to write the differential equations. For the first free body diagram for M1, we can write by Newton's second law, applied force, sum of applied forces is equal to sum of opposing forces. That is, we can write F of t equal to Fm1 plus Fb plus Fk1 plus Fk2. That is, F of t equals Fm1 is m1 d square y by dt square plus Fb is b into dy1 divided by dt. So here y1 plus Fk1 is k1 into y1 plus Fk2 is k2 into, here both this M1 and M2 are in contact with this K2. So we have to write K2 into, while considering this M1, we can write Y1 minus Y2. While considering M2, we have to write Y2 minus Y1. So here K2 into Y1 minus Y2. Now let us take the Laplace transform. Laplace transform of f of t is f of s equals m1 into s square y1 of s plus b into s y1 of s plus k1 y1 of s plus k2 into y1 of s minus y2 of s. Here we can write m1 s square plus bs plus k1 plus k2 into y2 into y1 of s. That is y1 of s we can take outside. Then plus y2 of s into k2. So this is f of s is equal to m1 s square plus bs plus k1 plus k2 into y1 of s plus y2 of s into, sorry, here minus y2 of s into k2. Now considering the mass m2, so here we can write f m2 plus f k2 equal to 0. So here only opposing forces are there. So we can write fm2 plus fk2 equal to 0, and that is fm2 is m2 into d square y2 divided by dt square plus k2 into, here we have to write y2 minus y1 equal to 0. So here while taking Laplace transform we get m2 into s square y2 of s plus k2 into y2 of s minus y1 of s. That is m2 s square y2 of s plus k2 into y2 of s minus y1 of s equal to 0. So here y2 of s we can take outside, that is m2 s square plus k2 minus y1 of s into k2 equal to 0. So here we can write y1 of s into k2 equal to y2 of s into m2 s square plus k2, that is y1 of s equal to y2 of s into m2 s square plus k2 divided by k2. The previous equation was, so this is second equation, and the previous equation was y1 of s into m1 s square plus bs plus k1 plus k2 minus y2 of s into k2 equal to f of s. So this is the first equation and this is the second equation, and the question is we have to find y2 of s divided by f of s. So here we have to substitute for y1 of s, that is substitute equation 2 in equation 1, that is equation 2 in equation 1, that is for y1 of s we have to write this y2 of s into m2 s square plus k2 divided by k2, that is y2 of s m2 s square plus k2 divided by k2, then this one, that is m1 s square plus bs plus k1 plus k2, then minus y2 of s into k2 equal to f of s. Now this y2 of s we can take outside, that is y2 of s into m2 s square plus k2 into m1 s square plus bs plus k1 plus k2. This k2 we can take to this side, that is taking the LCM, minus K2 square whole divided by K2 and equal to f of s. Now the transfer function y2 of s divided by f of s equal to, so y2 of s divided by f of s is taking the reciprocal of this one, that is K2 divided by m2 s square plus K2 into m1 s square plus bs plus k1 plus k2 minus k2 square. So this is the transfer function of the given system. Let us do another example. Write the equations of motion in S domain for the system shown in figure. Determine the transfer function of the system. So this is the given figure. So here there are two nodes. One is this mass M and another is the meeting point of spring and dashboard. So there are two nodes. One is this mass and another is meeting point of the spring and dashboard. So first of all, draw the free body diagram of this mass M, that is here F of t is the applied force, F m is the opposing force of this mass, then there is one dashpot B1 and B2 here. So FB1 and FB2 we have to write. So this is, and x is the displacement. Now we can write f of t equal to fm plus fb1 plus fb2. That is, we can write the differential equations. F of t equals m into d square x by dt square plus b1 into dx by dt plus b2 into dx by, sorry, here while writing b2 we have to consider this displacement and the displacement by this point, that is, let it be x1. So we can write x minus d of x minus x1 divided by dt. So assume x1 is the displacement at this point, that is at the meeting point of the spring and dashpot. Now taking the Laplace transform, f of s is equal to m into s square x of s plus b1 into s x of s plus b2 into s x of s minus x1 of s. On rearranging, we get m s square plus b1 plus b2 into s x of s minus b2s into x1 of s equal to f of s. Now consider the second node, that is the node at this meeting point. So here only opposing forces are there, Fk and Fb2. That is free body diagram for that one, that is m is equal to 0. Mass is assuming as 0, then displacement is x1. Opposing forces are Fk and Fb2. That is, we can write Fk plus Fb2 equal to 0. Now write the differential equations, that is k into x1 plus b2 into d by dt of, here x1 minus x we have to write, and that is equal to 0. Now take the Laplace transform, that is k into x1 of s plus b2 s into x1 of s minus x of s equal to 0. Now rearranging, that is x1 of s we can take outside, that is b2s plus k into x1 of s minus b2s into x of s equal to 0. That is x1 of s equal to, we can write b2s divided by b2s plus k into x of s. So this is the second equation, and the first equation was f of s equal to ms square x of s plus b1 s, sorry, b1 plus b2 into s x of s minus b2 s x1 of s. So this is the first equation and this is the second equation. So these two are the equations of motion in s domain. Now we have to find the transfer function. To find the transfer function, so the transfer function is x of s divided by f of s. So to find that, we have to put the value of x1 of s in this equation, that is put x1 of s in equation 1. So we get f of s equal to ms square plus b1 plus b2 into s x of s minus b2s into, for x1 of s we have to substitute this value, that is b2s divided by b2s plus k into x of s. Now taking the LCM, f of s equal to, take the LCM, that is m square plus b1 plus b2 into s into b2s plus k minus b2 square b2s the whole square divided by b2s plus k into x of s. So the transfer function x of s divided by f of s equal to b2s plus k divided by m square plus b1 plus b2 into s into this b2s plus k, then minus b2s the whole square. So this is the transfer function of the given system. Thank you for watching the class. If you like the classes, Please like, share and subscribe my channel.